If you recall, we looked at a whole heap of what the basic curves are and what they look like. And what I said was, you can create any one by use of transformations. That's what we're now going to look at, transformations. So the first one is translating. Translating just means shifting. So if we want to do a horizontal shift, we replace x with x minus h. So function x becomes function x minus h. We know it's a horizontal shift because the h is grouped with the x, right? And x controls the domain, so that'll give you a horizontal shift. So basically we're going to shift left or right depending on whether h is positive or negative, so many units. Now if you're ever unsure, then just look at x minus h. If you want to know where the origin has been moved to, then you solve x minus h equals 0, and that will tell you where 0 has been moved to. Vertical shift, we group it with the y, because y controlled the range or the vertical height of our graph. So technically it's this, y minus k is equal to function x. Mind you, we normally see the equations written more like that, where it's y equals function x plus k. But as I say, technically it's y minus k because it's grouped with the y value. It can't go with the x value because x is inside the function. So k could only go with the y value here. So it will move it up or down, depending on whether k is positive or negative. And so again, if you are unsure, then you would solve y minus k equals 0, and that will tell you where the origin has gone to. So let's look at some. We want to draw y equals x minus 3 squared plus 4. So we had some quadratic, we've ended up completing the square, and we've got it in this form. Well, the first thing I notice is the basic curve would be y equals x squared. So I've drawn that in. Then what's happened to it? Well, I notice grouped with the x is negative 3. So I know we've shifted it right 3 units. So let's do that. Slide it over. But we've also got this plus 4 over here, which means we have shifted it up 4 units. So let's do that. And there's our new parabola. And the vertex is at 3, 4. Okay? We'll do this one. X squared plus 2x plus y squared minus 4y minus 4 equals 0. Now hopefully we recognise that's going to be a circle, because the coefficient of x squared and y squared is the same. They're both 1. So what I might do then is complete the square to get into a form that I'm used to seeing. So half the coefficient of x is 1, so I know I've got x plus 1 squared. Half the coefficient of y is negative 2, so I've got y minus 2 squared. But to keep it all balanced, I need to add in 1 and 4, or 1 squared and 2 squared if you prefer. So we end up with equals 9. Now let's pretend we don't know what this is, other than it's a circle. So I know my basic circle would be x squared plus y squared equals the radius squared, or in this case 9. But what have we done to it? Well, we notice the x plus 1, so we have shifted it left 1 unit. But also, it's been shifted up 2 units, because the negative 2 is grouped with the y. So we'll shift it up 2 units. And there's the location of our new circle. Centre is at minus 1, 2. I suppose I should have written in the radius there. I didn't do that. But the radius is, of course, 3. Y equals 2x squared plus 8x plus 5. First thing I'm going to do here is divide everything by 2. The reason I do that, I just find it's easier to complete the square when I've got x squared rather than 2x squared. So let's complete the square, and I get x plus 2 squared minus 3 on 2. But now I'll multiply by 2, so I've got y equals, so I'll get that 2 back in there. So I've got 2 outside x plus 2 squared minus 3. So what does this one do? Again, it starts with our basic curve y equals x squared. What have we done to it? Now this 2 out the front, we'll look at this in a bit more detail later, but that will basically make our curve steeper, because y equals 2x squared rather than x squared. Now grouped with the x, so we shift it left 2 units, slide it across, but we'll shift it down 3 units. And so there's our new parabola. All right, so that was translating. Let's have a look at reflecting. A vertical reflection is when we replace x with negative x. So it's a vertical reflection. So we replace x with minus x. So in other words, we should see y equals function negative x. So that will reflect in the y-axis. Now if you want to reflect in a different vertical line, so x equals a, then we would replace x with 2a minus x. Let me show you why. There's some random curve y equals function x. If I wanted to draw 2a minus x, the minus x we reflected in the y-axis. 2a minus x, I now shift that to a. Now if you have a look at my final curve and the original curve, you can see that, oh look, that actually is a reflection in a. So a lot of people make the mistake of thinking it should be a minus x, but it's actually 2a minus x that it would be. Horizontal, similar thing, but now we're replacing y with negative y. So we'll end up with negative y equals function x, but again, we probably don't normally see it written like that. We're so used to having equations as y equals. We're probably more used to seeing it as y equals negative function x. But again, that negative sign is actually associated with the y value because the negative isn't inside the function, it's outside the function. Now we can do a similar thing. If we wanted to reflect in a different line, same idea, but this time I'll change y with 2a minus y. So in other words, y would end up becoming 2a minus function x. Let's do one. There's function x. Well, minus function x, it would reflect in the x-axis. Then 2a, shifted up 2a. Again, if you have a look at the final one I drew and the original one, it's a reflection in y equals a. So that's how you could reflect in a different line. Reflection in the origin. You might be thinking, hang on, reflection in the origin? Well, that is actually rotation. So it's when you've made both of the negatives, you end up with y equals negative function negative x. Reflection in the origin has the effect of rotating 180 degrees. We've seen that somewhere before, minus function minus x. And it was when we were trying to prove odd functions. Odd functions had rotation of 180 degrees, so it's not a coincidence. So in fact, what we've really done is two reflections. We reflected the x-axis, then we reflected in the y-axis. So let's say this is the original curve. If I was to do y equals minus function x, so that would reflect in the x-axis, so I've reflected it down. But now, that new shape, I'm going to reflect in the y-axis, and I hope you can see, you look at the original one, you look at the new one, what we've basically done is rotated at 180 degrees. All right, so now we're going to draw this. Minus x plus 1 cubed plus 2. Well, the basic curve is y equals x cubed. What have we done to it? Well, the first thing, I'm going to reflect in the x-axis, right? Because it's minus x plus 1. It's not grouped with the x, it's grouped with the y. So let's do that. Now, we've shifted the curve left 1 unit. So I'll slide that over. Then we've shifted it up 2 units. And there's our picture. So the origin has moved to the point minus 1, 2. Y equals minus 2 to the power of minus x. Now remember, that's minus all of 2 to the minus x. If they wanted, for some reason, minus 2 to the power of minus x, the minus 2 would have to be in parentheses for this. So this is minus 2 minus x. So I'll start with our basic curve, our basic exponential, y equals 2 to the power of x. What have we done to it? Well, it's a reflection in the origin. The negative is both with the x and the y as well. So we'll rotate it. Bingo. So 4a, 4b. We return to drawing curves. I know you love drawing curves.